Okay. Let's take roll really quickly. All right. Here we go. Ian.
Here.
Alex, bye.
Here.
What it do, nephew? Oh, Alan. Where's Alan? Oh, hello, Alan.
Oh, hello, here.
Okay, over here. Oh, the chosen one. You say, oh, okay. Umatasai.
Hi.
William Gata, Ada, Ada,
Here.
Grasic. Eleanor, she's international. Lance Matthews. You look a little hyper today, Lance.
Yeah,
Wolverine. How we doing, brother?
I'm here.
Good. Dylan, the second chosen one.
I'm here.
Danny Anos. He's blurry. And Getty Woo.
Hello.
Hi, how are you, Gary? So serious today.
I'm tired.
Oh, hold on. Let me get my carrying jar. Oh, I don't have one. All right. So if you guys check your email, your quiz is in your email. Go on and take it right now. It is 6 minutes. Okay. So I believe, hold on one second. I believe, let me just make sure that it is 6 minutes. It might be 7. It is 6 minutes, okay? So when you start it right off the bat, go ahead. And what I want you guys to do is when you're done, just kind of just clap your fingers and just go like that so that I'm aware that you guys are done. And then after you're done with your quiz, after it's submitted, go ahead and just open up a Java project or get Eclipse ready to go. You may begin. Look at this stuff. Isn't it neat?
Mr. Martinez?
No questions.
No, my test isn't working. Like the link just sends me to the website, doesn't show up the test.
Which one?
The one in the email.
Who's saying this?
Eon.
Does anybody else have that issue?
No.
Try clicking on it again, and it's something wrong with you. I'll put the link in the chat.
Oh, never mind. I'm just dumb.
You said it. Remember, not everyone was meant to graduate. Yuben, chai heso. Don't nod your head in approval. My Korean skills are off the chain.
It was not bad. I understood it.
No, I meant good job. Thank you. Woo! Nice rebound, Logan. Good job, bye. Lance. 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 Nice job, bro.
Kind of disturbing.
What's that?
It's kind of disturbing.
You're kind of disturbing.
No, that was.
Just waiting for Henry and Gary. What's up, Uma?
I just finished.
I'm gonna dip.
You're gonna dip?
Yeah, I'm gonna go.
Do you have to leave the class? Oh yeah, you told me. You told me.
Yeah.
Okay, cool.
Bye.
Yeah. Watch the video. I'll see you later. Put that in. I'm just waiting for Gary.
I already submitted mine though.
Oh, did you? Okay. You're right. For some reason, I didn't see it. One on the second page. many kids do I have? I have 13. Okay, cool. All right, so the quiz, what do you guys think? Hard, easy? Okay, as you can see, that one probably medium. We got a lot of perfect scores in here. You have to review every day. Again, this is not principles, okay? I'm definitely gonna go at you, okay, to try. Now, this is a quiz as soon as Eleanor takes a quiz, we can review this next class. So unfortunately I can't, but this is a quiz that I would definitely want to review with her, okay? So that being said, let's see. Okay, get Eclipse ready to go. Okay, here we go. And again, guys, so just giving you a heads up, I do my best to try to make the quizzes different from one class to another. Sometimes I don't have time. So please do not share any of the quiz questions with anybody. Understood? Okay. All right. And especially, yeah. Okay, great. All right. So here we go. Let's get started. Okay. So make a new project. Okay. And called operators, and make a new class called tester. Okay. Make a new project called, what's it called? A new project called operators. And then what's it called? A new tester class. Okay, so basically what today is, it's for some of you guys, it's just going to be going over just some simple rules and simple assignments. I'm not going to go over the naming declarations. For example, I'm not going to be, what's it called? I'm not going to be going over small, like little things like the naming conventions, but I'm just going to go over some simple rules, and then we're going to go over the standard operators, okay? So when we're naming a variable, I think the key thing that we want to cover is, for example, what is this process called?
Initial declaration.
Declaration, okay? What is this process called?
Initialization.
Okay, so key thing, you have your empty box here that you've created that's on your left. The value is on the right, okay? I call this Beyonce rule, okay? Because when you're making variables, everything goes to the left, to the left. Everything you own in a box to the left. If I bought it, that's my stuff. Please don't touch, okay? The Beyonce rule. Now, obviously, this is not a rule that really exists in programming, but it's just something to keep in mind. I do have kids that on occasion will do this. Okay? That is not legal, all right? So, that being said, let's continue on. All right, so what we're going to be doing today is we're basically going to be going over the operators, the standard operators, mathematical operators that you're going to need to know, okay? Now, algebraic operators, okay? Most of them are the same, all right? Actually, let me go ahead and just do this in algebra, all right? So, let's take a look. Now, when we're going over algebraic operators, the first one we're going to look at is, let's see. Dylan, what is this?
Addition.
Okay, very good.
Adding.
Huh?
Oh,
Addition.
sounds like you needed clarification.
Very good. So if I say int j equals 5, int k equals 6, and I print out j plus k. Okay. Oops, I forgot.
It says int k.
Ink. Okay, sorry about that. All right. So if I say int k and I do that, okay, I get 11. It's addition. Okay. I'm also capable of storing it like this. Int jk or int jki equals j plus k. Now, is this legal? Why is this legal?
Because the product, the sum of J and K is still a
Well,
whole
no. Are both of them ints?
Yeah, an int plus an int is still an int.
Yeah,
Still can
exactly.
be stored in
So
an
can
int.
I still store two ints inside of an int? Yes, I can. Okay. So j plus k just simply in its map. What is this sign?
Subtract. That's a minus sign. It's subtraction.
Negative sign.
A negative sign or addition. Now this is so here's
Addition.
okay. Oh, whoops. Subtraction. All right. So this is something that you guys should know also. The negative sign is the only symbol that actually gets treated as that can basically, what's the best way to say it? The distributive property. Okay, it's the only symbol in programming that is allowed to do it. Now, if I say j minus k, very simple, boom, okay, shows us. So we have subtraction. The next one, we don't use an X for multiplication, as you guys know, okay? We use the asterisk. Multiplication. Okay? I multiply. 11, negative 1, 30. Okay? Then we have division. Okay? So if I do this, right? J divided by K. There we go. Okay. Now it's 0. Now let's talk about this for a second. Okay. Division is very important. All right. Now, when it comes to division, depends on what you are doing. Okay. So let's take a look at the numbers here. Let's take a look at, let's say make 10, J10 and K6. Okay. What's 10 divided by 5?
2.
2. Okay. 2. All right. But what if I make this 10 divided by 8?
1.
It should be 1 point something, correct? But we only get 1. The reason why is there's a process that happens, okay, with division. So in this instance, this process is called truncation. Anything, so for example, this should print out 1.14 whatever, okay? And what truncation says is, you know what? Go ahead and from the decimal, get rid of everything. More importantly, it doesn't round. It does not round, okay? So it's, even if it was 1.999, it is 1. And why do we chop off the decimal? Gata, why do we chop off the decimal?
Because ints can't hold decimals.
Bingo, exactly. But let's say, for example, I made J a double. Okay, we'll get rid of this for right now. And I run this. I get 1.25. When you are dividing, if you ever come across like some type of thing, if you ever come across a symbol that does have a, how do you say, if you ever come by a symbol that, like, what's it called, that has a double, if you ever come by a mathematical equation, the double kicks in. So for example, let's take a look at this. First, let's do some practice, okay? Just some practice. Take a look at this. Okay, what do you think this is going to print out? Don't run it, don't copy it, just do the math in your head. Remember that PEMDAS rules still apply.
10.
Okay, should print out 10. Okay, which do we do first? 3 times 4, right? Which is 12. 5 plus 12 is 17. 17 minus 7 is 10. Okay, so when we run this, we get 10. What about this one? Oops. Oh, what the hell? Hold on. What about this one? What about this one?
1.
Which one? What do we do first?
Parentheses.
This becomes a what?
Negative one.
A negative 1. What's 5 times 6?
3.
30 divided by 3 is
10.
10. Negative 1 times 3 is
Negative 3.
negative 3. Okay, so we have 8 minus a negative 3, or negative, I'm sorry, what is it? Sorry, 30 divided by 10. So 8 minus 10 is what?
Negative 2.
Negative 2 plus negative 3 is?
1.
Really? Negative 2 plus negative 3? Is
I
Negative
don't know how to
5.
do math anymore.
Mr. Eon answering machine.
Really? Sierra Canyon math. Yay.
On
Yeah,
the math team, my dude.
that's why I'm in calc.
Oh, God. Jeez. All right. Tillman would hate you guys right now. And not just because you're bad at math. All right. So, okay, it would print a negative 5. Bingo. All right. So, but let's take a look. So we see basically what I wanted you guys to do is just get in the mind of PEMDAS. Honestly, guys, when it comes even to the AP question or to AP test, you'll probably encounter some math that you'll have to do on the multiple choice. You won't ever encounter it on the free response. Okay. And the math that they have you do, it's not going to be too big. Okay. So we have 8 minus 5 times 3. So let's mix it up a little bit. Let's take a look at this equation. 5 plus 3 divided by 2.0 plus 6. What is this going to yield?
Isn't it gonna break?
12.5.
12.5.
It can be 12.5, right? You think?
Yeah.
Ooh, 12.5. Okay. What if I did this?
12.
Notice that it's 12. But now I'm going to mix it up. 6.0.
12.0.
Okay. It's 12.0 is correct. The biggest mistake that some people do is they see the double. The minute that you see the decimal, you should know. And I will quiz you guys. I will give you a hard as hell math question. And 3 of the, I'm telling you right now because I do it on the AP and I'm just as mean. They will give you a question where it's a hard ass math problem and you have 4 questions. 3 of them are ints and 1's a double. Always look at your answers first. If you see a double, one of the options isn't none of the above, and you have 3 ints and 1 double, do you even need to do the work?
No.
No. Work smart, not hard. Okay? Or as they say in Korea, omyamaseyo. All right? So, okay, now, system dot print line 5 plus 3 divided by 2, 6.0. Okay, the other thing again is this. You only use the decimal. The decimal only goes, you basically start using it from when you first encounter it. I have a lot of students that will think, oh, decimal, that means that this is going to be 1.5. No, doesn't work that way. Whenever you get to the decimal, so for example, you might encounter the decimal right away in the very first equation. Okay, that could make things tricky. But in this instance, we don't encounter the decimal till the very end. So here, 3 divided by 2, truncation happens, it's a 1. 5 plus 1 is 6 plus 6.0. Ah, now we add the decimal to our equation. So critical rule, only apply the decimal when you get to it. Sound good? Okay, perfect. All right, So that covers truncation. And again, remember, decimal variables always take precedence. If you see a decimal, it could be 20 inches long and you have one decimal, that decimal takes over. That being said as well, what type of number is this?
A double.
A double. Perfect. Okay. So now this one right here, modulus. Now, modulus is the percent sign. So modulus, again, is what we call the remainder operator. It's the remainder operator. So I'm going to just change, I'm going to change this back to int for right now. Okay. So let's say that I do j modular k. This prints out 2. Modulus basically is saying, think of long division. 8 goes into 10 how many times? Once, with a remainder of 2. Let's say that I made this 6. How many times does 6 go into 10?
One.
Huh? 1 time, with a remainder of 4. Okay? So one rule, we don't have to, there's usually 2 rules, but they don't ever test that first rule. This rule you do need to know. Let's say that this side is A and this side is B. If A is less than B, it spits back A. So for example, right now, J is 10. Let's say I make K 16. Is side A less than side B? Is it? Yes, it is. I run it, it spits back 10. Key rule you need to remember, if A is less than B, it spits back A. So we have, anybody have confusion with addition? Anybody have confusion with subtraction? Multiplication, division, you need to know the division truncation. Also, what's built into division is you'll get an error if you try to divide by 0. Okay. And then last we have modulus. Okay. So that being said, let's move on to our compound operators. Okay, we're going to use J and K still, all right? So let me copy them and I'm going to bring them down here just as references so that we see what J and K are, okay? So these are what we call our compound operators, okay? Basically, they do 2 things in one. So first thing, so let's say that I have, actually, you know what, I'll work with it. I'll say int x equals 5. I am allowed to say x equals x plus 5. Okay, I am allowed to say that. All right, this is what we call a compound operator. Okay, and basically what this is saying is you have to look at it this way. The new value of x is equal to the old value plus 5. So now if I were to print out x, what do you think it is?
10.
10. Bingo, it's 10. Here's the important part. When I did plus, minus, multiplication, division, did the values of the variables change?
No.
No, they didn't. Compound operators, you are overriding the value. You are overriding it, okay? So we have an x, I'm gonna just copy all of this. So this is basically your addition one. I think you guys can all see that. So we have addition, and basically we have one for every single operator. There is one for minus. That would take us back to 5. There is one for multiplication. This would take us to 25. There is one for division. This would bring us back to 5 as well. Okay. And then I have modulus. Who can tell me what this is going to print out?
0.
0. No matter what, everything has been a multiple of 5. So that means I can divide into it. So there should be a remainder of 0. Now, so if again, you are printing out x, that means from this point forward, x is now equal to the value of 0. Compound operators change the value of the variable. I don't know why I'm banging on my desk, but I guess it's like dramatic effect to get the point across. Is it working, Thanos? No. Thanks for that. You could just at least lie to me. All right. Thank you. All right. So that being said, when we were trying to save space in the 80s and 90s with RAM, there are other ways that you can write this, okay, in order to save space. So x equals x plus 5 can also be written as plus equals. This can be written as minus equals. Who can guess what this one can be written as?
Asterisk equals.
Times equals 5. Yes, very good. Division is x. Division equals 5. And last, x modular equals 5. Okay? Both ways work. On the AP, it is customary to see this format here. Will you see some free responses that look, or some multiple choice questions that look like this? Yeah, you might run into a couple, but it's customary to kind of look at it this way, x plus equals 5. The key thing again, compound operators change the value of the variable. Okay? Do standard operators change the value? 9. 9 is German for no. Okay? And then we have compound operators. Again, the way we read it, the new value is equal to the old value and then plus 5 minus plus 7 times 2, whatever it is, okay? Boom. Yay. Hooray. Okay? Now, let's go into the last thing that we kind of need to know today, incremental and decremental. Incremental and decremental operators, okay? All right. How many of you guys have ever heard of a language called C? Okay. C, when they came up with C, great little language, so much fun, but it was kind of archaic, so they came out with a new version. How many of you guys have ever heard C++? C++, the plus in Java basically means add 1. So it's the nerdy way of saying C plus 1. It's like 2. I hate my life. All right. So plus basically means add 1. So we already have x is equal to 0 at this point. So let's say that right here I say x plus plus, and then I print out x. What do you think is going to happen? What's it going to print out by? And only by?
6, no, 1.
1. Okay, because this was 0. Hint, hint, use the past. We use the past to learn our future. Ugh. All right, so plus means add 1. Okay. Let's see. Logs, Wolverine. What do you think minus does? This is a tough one. Huh?
It subtracts 1.
Subtracts 1. You, my friend, are a genius. Okay? It subtracts 1. So if I change this to x minus, what do you think it's going to print out? Alan. Oh, Alan.
Oh, it should be 0.
very wrong. Negative ye. Because remember, I did it here. It will be -1.
Oh.
So I just changed it from over here. Now, let's take a look at something really quickly, okay? Take a look at this. And some of you, so I'm going to call on people that I haven't had. Some of you might know this, okay? You are allowed to also do this. This equals 1. This equals -1. But what's important is when you use it, okay? This is important, all right? So, for example, right now, at this point, x is equal to 0. Do we all agree? But Eubin, what is x equal to now?
Oh. Still 0.
Is it? Is it?
Is it?
Don't ask me. I'm the teacher. I ask the questions. Chosen one, number 2. What is it?
1.
I need somebody with a sure answer. I don't need any of this hesitation junk.
It should be 1, right? That's how that works, I
Give
think.
you 1. Yet the first chosen one was correct.
Darn.
Okay? It's 0. But x is actually 1. Oh! Oh, heavens to Betsy's, grab me pearls. Okay, and here is why. Okay? When you have the plus on the right, basically think of it as an algebraic 2-step equation. Okay? First, run the print statement, and then, then add 1 on the back end. But take a look if I do this. Right now it was 0, 1. If I run this, 1, 1. If it is on the left, the 2-step equation says, okay, add 1 to me first, then add 1 to me first, then print it out. Okay? Now, you go ahead and you apply this. Let's take a look, okay? And some of you are going to remember this and have recurring nightmares. Let's take a look at this equation. Okay? So what I want you to do is I want you to tell me what this prints out and then what x prints out. I'm going to just go ahead and make this a block comment so that we can see. Okay. What prints out? So let me make int x. I'm going to say int x. Hold on. Calm down, Turbo. You don't even know what x is. Boom. The flowers are still standing.
Would it be a? Yeah.
Anytime. Now, give
It
me a
prints
heads
out
up.
12 and x prints out 6.
All right. How many of you got 6? What'd you say, chosen one? Second one?
The first prints out 12 and the second one prints out 6.
Okay, let's see if Dylan, for once in his life, is right. Okay. Now,
I'm always right. Don't know it yet.
oh, I saw your quiz. That's not true. Oh, busted. You get, Dylan, welcome to the class. I expect you to roast me just as hard as I'm roasting you. All right, it's a two-way.
Am I allowed to?
Allison
Can I
Ho,
correct you?
Allison Ho rips me apart, so feel free, okay? And she doesn't talk, I think,
Well,
in any of her classes. So-
Hold up. Okay, wait. Let me correct one statement you made earlier. You said
Okay.
that.
Oh, shucks, you got muted. Shut up. All right, now, so All right, so now, first one is 3. Before we use 3, we're going to go left to right, simple PEMDAS, okay? Left to right. What is the value of x before we start using it? 4. So 4 plus, now before we use the value, we add 1 to it. So now this would be 5. So first off, to the first one, it's 4. Then it became 5, okay? Plus, it's two-step equation here. Use the value first, which would be 5. So 4 plus 5 is 9. 9 plus 5 is 14. But this became 6. And 14 minus 2 is 12. Okay? 12 and 6. But let's throw a little wrench in this. What is it now? So you already know the value of x up to here should be 6, okay? So you know at this point this is 12. What is going to print out? 18 or 19? Very simple. It's the end of the print statement.
18. 18.
18. And the reason why? We have finished. Technically, this is the end. If we ever end on a plus plus or a minus minus, if it's ever the last thing, use the current value, which would be 18, but don't forget to add 1 on the back end. So the value is 7, but we only used this. If you ever end on it, okay? So where it starts, so for example, if I started off with x plus plus, I would use 3 first and then add 4. Then, so now this is a completely different equation. What is this now? What's the answer now? Take a look at this equation now.
17.
So this is what? The first x is what? 3.
3.
Okay. Then we add 1 to it. It becomes 4 plus, and we add 1. So this is actually 3 plus 5 is 8. 8 plus 5 is 13. Okay, then it becomes 6. 13 minus 2 is 11. 11 plus 6 is 17. Okay, x still stayed the same. This is something that you guys can always get right. You will have to do the math here. This is going to be funny. But if you go through, okay, I have 1x here, I have 1x here, I have an increment here, and I have an increment here. If you just count all of those, 4 times I've incremented, 3 plus 4 is 7. You should always get this question right. Understood? That one you should always get right. Where I try to trick you is the locations of the plus pluses and the minus minuses, okay? Whether they be on the left or right. Now I can tell you, you're generally going to see this in loops. This is not tested on the AP. Plus plus is not tested. You won't ever use it. 9 times out of 10, their problems will be written like this. Every multiple choice and free response question you get will be written like this. Sound good? Okay, so that being said, that's pretty much it. There shouldn't be any other questions. Okay, so what I'm going to have you guys do, just to, kind of just get you guys, I'm going to have you guys do questions 1 through 18 evens. 1 through 18's even, and then when we are going to do the cheating on your arithmetic assignment, we're going to do that. Make sure you read it. And cheating on your arithmetic, we will do that together as a class in class, okay? So again, know your operators. There's some special things that we have to do with strings. I will get to that later when we go into strings and null and stuff like that. So don't worry about addition with strings. Know your operators, know your compound operators, okay? And know your incremental and decremental operators, okay? So for example, if I ever ask a question, what are the 3 ways to add 1 to x? Okay, let's say right here, what are the 3 ways to add 1 to x? We could say x plus x equals x plus 1, right? I could also say x plus plus. I could also say x plus equals 1. All of those are legal. All are fair game. Okay? Just get into the habit, know them. Again, guys, as you can see, it's really, make flashcards if you need to, or just rewatch this again. But you need to know these. And again, remember that Java is a language. Even though you're just learning it now, it's not like, if you guys remember, like in the quiz, what did I throw at you? What did I throw at you? You had to have knowledge of the bit rate of something, correct? For an int. So that's what I'm talking about. Everything that you learn, you're gonna need to know. We learned system.out.print on the first day. You're gonna need to know it 7 months from now. It's a language. Let's build up our language together, okay? So I will have this again, chapter 4, 1 through 18. Tuesday will be a review day. Wednesday is your exam. 10 multiple choice, 10 short answer, 1 code. Now also, I'll say this again, but like when you're doing the code, giving you the heads up, you will assume that the main method is already written. Do not write the class and do not write the method name. I will tell you that you're just giving me basically the body of the program. All right? So I hope to see some of you at back to school night later today. Otherwise, you're not going to see this beautiful face for at least 4 days. Don't cry. Don't cry. I already see the tears, Lance. It's okay. Alex, how dare you cheer? So, all right. So have a great time, guys. Gary, I'll miss you as usual. Okay. So
Gary X, Mr. Martinez. Ship
What?
of the class.
what?
Wait,
What?
do you have to go to that back to school night thing, or?
I think it's required. I think it's mandatory. I've got to meet all your parents. They have to see the nut job who's teaching their children.
Okay.
All right. So, but some of you I've already met. I think I've already met Danos, Ian's parents. I haven't met Alex's. I haven't met the Matthews brothers. Euban, I haven't met yours. I've met your mom, Dylan, but just through at Sierra Canyon. So, but other than that, look forward to seeing everybody. Zip it up and zip it out. Be good and stay out of gangs.